So, have you ever wondered how an AI agent goes from just a cool idea on a laptop to a real production ready system that a business can actually rely on? Well, today, we're going to break down the playbook that makes that happen. This quote right here, it just hits the nail on the head. Honestly, spinning up a quick demo of an agent, that can take just a few minutes. But actually making it reliable and safe and something you can trust, that's the hard part. It's what separates a fun little experiment from a tool that brings real business value. Because, let's be real, skipping that last mile can have some pretty severe consequences. And we're not just talking about minor bugs here. We're talking about major business disasters. Imagine a customer service agent getting tricked into giving away free stuff, or a user somehow getting access to confidential company data. Or maybe you come in Monday morning to a massive unexpected bill because an agent ran wild over the weekend. These are the kinds of things that happen when you don't take production readiness seriously. And all of this brings us to what we call the production gap. Now, this 80% number, it's pretty wild because it shows you a really important truth. Most of the work isn't even building the agent's brain, its core intelligence. Nope, it's in everything else, the error handling, the security checks, the performance testing, all the less glamorous but absolutely essential engineering you need to make it dependable in the real world. So, to bridge this gap, we can't just rely on our old playbooks like DevOps or MLOps. Agents, they're a whole different animal. They're autonomous, they're interactive, and they remember things from one conversation to the next. This new challenge demands a new specialized discipline, and we call it AgentOps. It's designed from the ground up to handle these unique operational challenges. Okay, so how do we build that trust? Well, it all starts way before you ever launch. The real key here is to create a system that automatically proves its own quality and safety. You want to get away from manual spot checking and just hoping for the best, and move to a world of automated confidence before a single user ever touches it. The entire pre-production process is really built on this one powerful idea. It's a simple, non-negotiable rule. No new version of your agent gets to users without first passing a whole suite of automated tests. These tests have to prove that it meets your standards for both quality and safety, period. And how do you enforce that rule? With an automated CI/CD pipeline. That's continuous integration and continuous deployment. The best way to think about it is like a funnel. Right at the beginning, before code is even merged, you run the fast, cheap checks. If it passes those, it moves down the funnel to a staging environment for more intense, expensive evaluations. Only after it passes every single one of those gates is it finally ready for a controlled release to production. The whole point is to catch errors as early and as cheaply as you possibly can. But here's the thing. Even with the best testing in the world is always going to be unpredictable. So you never just flip a switch and release to 100% of your users. That's where safe rollout strategies come in. With a canary release, for example, you expose the new version to just a tiny slice of users, maybe 1%, and watch what happens. Or a blue-green deployment, where you run 2 identical production environments, which gives you an instant undo button if anything goes wrong. It's all about minimizing risk. Now, a safe rollout is one part of managing risk. Building security in from the very beginning is the other, and it works in 3 layers. First, you define the agent's constitution. These are its core rules and principles. Then you build an enforcement layer of guardrails to block bad inputs. And finally, you create this continuous feedback loop of testing and red teaming to find and fix any weak spots before anyone can exploit them. All right, your agent is live. Now the challenge completely changes. You're not just a developer building a feature anymore. You're now managing an autonomous system that's interacting with thousands of people in real time. And that requires a continuous operational loop. And that loop is built on a simple but really powerful cycle. You observe the agent's behavior, you act in real time to handle any problems, and then you use what you learned to evolve the agent, making it smarter and safer over time. So let's break that down. The observe phase, that's like your agent's sensory system. You need logs to see what happened, traces to connect all the dots and understand why it happened, and metrics to get that high-level report card on how it's doing. Let me tell you, without this kind of observability, you're basically flying blind. But of course, just observing is useless if you don't do anything about it. So the act phase is all about real-time intervention. Think of these as the system's automated reflexes. This is where you pull all the operational levers.
like a circuit breaker that automatically shuts off a faulty tool, or a system that routes a weird request to a human for review. It's all about keeping things stable, right here, right now.
And finally, evolve is where you turn those quick, short-term fixes into permanent, long-term improvements. You analyze all the data from the observe phase to find the root cause of problems, and then you feed those insights right back into your CI/CD pipeline to develop and deploy a lasting fix. This is how every little hiccup in production actually makes the whole system better.
Okay, so you've mastered running a single agent. That's awesome. But what happens when your company has dozens of specialized agents, maybe all built by different teams? You can't just have them working in silos. You need them to collaborate and turn those isolated systems into a powerful, intelligent ecosystem.
Getting that collaboration right means you have to understand the difference between two key protocols. First, you've got MCP, the Model Context Protocol. This is for simple, one-off commands to a tool. It's basically saying, do this specific thing, like calculate this number. But then you have A to A, the agent-to-agent protocol, which is for complex back-and-forth collaboration. It's for delegating a high-level goal, saying, hey, achieve this complex outcome for me. And this auto repair shop analogy just perfectly explains how they work together. So a customer uses A2A to explain a complicated problem to a shop manager agent. The manager then uses A2A again to delegate the whole repair job to a specialized mechanic agent. That mechanic then uses MCP to call it simple tools, like a diagnostic scanner. And if it needs a part, it uses A2A one more time to negotiate an order with a totally separate part supplier agent. See how each protocol is used at just the right level?
So with all these pieces in place, the pre-production hardening, the in-production management, and the interoperability, let's zoom out and see how they all come together to form one single cohesive agent ops lifecycle.
The whole journey starts with a developer prototyping on their own machine. From there, their code enters the pre-production engine, where it gets hammered by the CI/CD pipeline and its evaluation gates before it can get a safe, controlled rollout. Once it's live, it enters that continuous observe, act, evolve loop in the production environment, turning real-world data into the next wave of improvements. It's a never-ending cycle. And that brings us right back to the question we started with. It's easy enough to build an agent, but as we've seen, making it truly trustworthy, well, that's the hard part. So as you look at your own projects, ask yourself this. Your agent is built, but is it really ready for the discipline and the rigor of that last mile?